Welcome to the History Stories podcast.
Great to be diving into another one.
Today, we're setting off on a historic road trip, really, to uncover a story that sounds almost, well, unbelievable. We're talking about the year summer just vanished.
Yeah, forget BBQs and sunny days. Try picturing this. You wake up in June, there's frost on the ground. You need, like, mittens in July.
Seriously, mittens in July.
Seriously. And forget fireworks outdoors on the 4th. People were apparently celebrating indoors, huddled around a fire. And this wasn't the Arctic Circle or anything.
No, this was 1816, happening in North America and Europe. They had some pretty bleak names for it, didn't they?
Oh, yeah. The poverty year. That tells you something. The year there was no summer. Pretty direct.
Yeah.
And the really chilling one, 1800 and froze to death.
Wow. Okay, so you hear that and you immediately think, what could possibly cause something like that? So widespread, so bizarre.
Exactly. It was just a freak weather pattern, some kind of, act of God or something else.
And the answer, which we found digging through the history books and uncovered sources, is maybe even stranger. It involves something that happened the year before, 1815, and literally halfway across the world.
A volcano. A monster volcano in Indonesia, Mount Tambora.
So our mission today on this historic road trip is to unpack that connection. How does a mountain exploding over there lead to snow in New England in June?
And constant dreary rain in Switzerland, for example. We'll dig into what happened in 1815, that colossal eruption, and then the absolutely crazy year that followed. It really changed how we understood the planet works.
Okay, let's start the trip in Indonesia, island of Sumbawa. Before April 1815, Mount Tambora was this huge, majestic peak, right? Over 13,000 feet tall.
Massive. But interestingly, it wasn't silent before the big one. It had actually started showing signs of unrest. Oh, back around 1812. Little rumbles, smoke.
So it's kind of simmering, giving warnings.
You could say that, yeah, like the earth was clearing its throat, maybe. There were reports of rumbling sounds, dark clouds near the peak. It wasn't entirely a bolt from the blue.
Then comes April 5th, 1815. The main event starts. And the explosions. They were heard over 900 miles away.
900 miles.
Yeah.
Think about that. It was so loud that people on the island of Java thought it was cannon fire, like a naval battle.
And they actually mobilized troops.
They did. That just gives you a sense of the scale, the sheer acoustic power. And then the next day, a sort of light ash started falling, a pretty ominous sign of what was coming.
Okay, but the real catastrophic finale was April 10th.
The evening of April 10th. Eyewitnesses described these 3 columns of flame shooting up, merging into one, making the whole mountain look like it was liquid fire.
Liquid fire, that's
Oh, yeah.
terrifying imagery.
And then pumice stones started raining down. Not pebble stones the size of dinner plates.
Yeah.
Followed by this thick, suffocating ash. It sounds, biblical almost.
It really does. And the eruption column itself, how high did that go?
Over 27 miles.
Yeah.
Straight up into the stratosphere. That's way, way above our normal weather systems, our clouds, everything.
27 miles.
And the explosions were heard even further away this time, over 1,600 miles. Houses hundreds of kilometers away were literally shaking from the shockwaves. This wasn't just noise, it was shaking the planet.
So putting this on the scale volcanologists use, the VEI, the Volcanic Explosivity Index, where did Tambora land?
It hit a 7. A VEI 7, which is huge.
How huge compared to others we might know, like Krakatoa or Pinatubo?
Right, good comparison. Tambora was about 10 times larger than Krakatoa or Mount Pinatubo in terms of the amount of material erupted. It's the largest volcanic eruption in recorded human history.
10 times. And the numbers, the ejecta.
We're talking somewhere between 30 and 50 cubic kilometers of rock blown out.
Right.
And crucially, an estimated 60 megatons of sulfur dioxide gas shot into the stratosphere. That number is key.
60 megatons of sulfur dioxide. We'll definitely come back to why that's so important. And the mountain itself.
It literally blew its top. Lost over 4,000 feet in height, just collapsed inwards, leaving this enormous hole, a caldera.
So the landscape was just completely changed.
Fundamentally, permanently, in a matter of days.
Let's pause here for our titans of fire comparison. Looking at the numbers really helps. Tambora. VEI 730-50 cubic kilometer ejecta, 43 kilometer plume height, leading to that estimated northern hemisphere summer cooling of 0.5 to 1 degree Celsius.
Right. And you compare it to, say, the Somalis eruption in 1257, also a VEI7, similar ejective volume, but some studies suggest maybe an even bigger temperature drop from that one.
Interesting. Why might that be?
Well, it raises questions. Maybe the exact chemical makeup of the ash and gas matters, or the latitude where the eruption happens. It's not just the VEI number, maybe.
And then you look at Krakatoa or Pinatubo,
Yeah.
VEI 6, significantly less ejecta, lower plume heights.
Exactly. It just highlights how Tambora was really in a class of zone in recent history. The scale was just immense. And even those early estimates linked the size to that temperature anomaly.
Okay, so back to Sambal Island, April 1815, the immediate aftermath.
Yeah.
It sounds like hell on earth.
It was apocalyptic. You had pyroclastic flows, these superheated clouds of gas and ash moving at incredible speeds, incinerating everything.
Instant death for anyone caught.
Instant death. Then tsunamis, maybe 10, 12 feet high, hitting the coasts. And then the ash fall, just relentless, burying entire villages under meters of ash.
Making water undrinkable, destroying any remaining crops.
Total crop failure, contaminated water, yeah. And the sky stayed dark, reportedly, for days. Just imagine the terror and confusion.
The initial death toll, directly from the eruption, was around 10 or 11,000 people.
That's the estimate, yes, but that's just the beginning of the tragedy.
Because the follow-on effects, starvation, disease, pushed the total number much higher.
Much, much higher. The estimates range from maybe 71,000 up to 120,000 people dead in total, making it the deadliest volcanic eruption in recorded history.
120,000 people, an entire local kingdom, the princedom of Tambora, was just wiped out.
Gone, obliterated. It's a chilling reminder of the localized, immediate, and absolute destructive power.
But now let's pivot to the global story. That sulfur dioxide, the 60 megatons shot into the stratosphere. That's the crucial link to the missing summer, right?
Absolutely. That's the smoking gun. See, unlike the heavier ash particles that fall out relatively quickly, this sulfur dioxide gas reacts way up there.
In the stratosphere, above the weather.
Exactly. Very stable layer. The SO2 converts into tiny droplets, aerosols of sulfuric acid, like a very fine, invisible mist.
Invisible but powerful.
Very powerful. Because these aerosols are so small and light, they can stay suspended up there for months, even years. And the high-altitude winds spread them right around the globe.
Forming a sort of veil.
A global veil, yes. Like an invisible parasol, reflecting sunlight back into space before it can reach and warm the surface.
Okay, so that explains the cooling, and also why people in 1816 didn't make the connection.
Precisely. The cause of the eruption was a year earlier, thousands of miles away. The effect, weird weather, cold, rain was delayed, subtle at first, and global.
How could they possibly link bad weather in New England to a volcano in Indonesia back then?
They couldn't, not with the science and communication they had. It highlights how hard it is to grasp these huge interconnected Earth systems without our modern tools.
So this stratospheric veil, this parasol effect, it plunged the northern hemisphere into what scientists call a volcanic winter.
Yeah, it wasn't just a slightly cool summer. It was a fundamental disruption. Persistent cold, way too much wetness in some places, and just dimness. Less sunlight getting through.
How much did the temperature actually drop?
Globally, the average land temperature dipped by about 1 degree Celsius, maybe 1.8 Fahrenheit, but that's an average.
Some places got hit harder.
Oh, yeah. Some regions might have seen cooling of up to 3 degrees Celsius or over 5 degrees Fahrenheit. Europe was hit particularly hard. Summer temps, there were maybe 2 to 4 degrees Celsius below mid-20th century averages.
2 to 4 degrees, that's huge for a summer average.
It made it the coldest summer on record in Europe for periods stretching over 200 years, from 1766 to 2000. Even in the U.S., Philadelphia's summer average was 5 degrees Fahrenheit below the modern record low.
And this wasn't just a blip, it lasted.
The chill lingered for 1, 2, even 3 years in varying degrees. And while 1 or 2 degrees might not sound like a catastrophe, averaged over a whole growing season.
It's devastating for agriculture.
Exactly. Crops have specific needs. Consistent chill, even if not deep freezes everywhere, messes everything up, especially when some areas did get those much deeper chills.
Like North America, the Northeast, U.S., Eastern Canada.
They got slammed. Repeated killing frosts. In May, okay, maybe not totally unheard of, but in June, July, even August.
Frost in August, that's just wrong.
Completely wrong. It decimated crops. People would replant hoping for the best, and then another frost would hit.
There were even reports of ice forming on ponds and rivers in Pennsylvania in summer.
Ice on ponds in Pennsylvania in July or August, that's hard to even imagine.
It tells you how extreme it was, not just chilly, but actually freezing, well into the warmest months. No wonder crops failed.
And then there was actual snow in summer.
Yeah. Albany, New York, parts of New England reported snow in early June. Vermont supposedly got nearly 20 inches.
20 inches of snow in June. That's the report. And near Quebec City, early July, accounts mention small flakes of snow mixed with the rain. Imagine seeing snow fall on your summer garden. The psychological impact must have been immense, bewildering, terrifying probably.
On top of the cold and snow, the weather was erratic too.
Totally unpredictable.
Yep.
You could have temperatures in the 80s or 90s Fahrenheit one day and then
Mhm.
plummeting down near freezing just days later. Wild swings.
And this weird dry fog.
Yeah, this persistent haze was widely reported. It dimmed the sunlight, made things gloomy. So much so that sunspots, which are usually hard to see without protection, apparently became visible to the naked eye sometimes.
Which must have freaked people out even more.
Definitely contributed to the sense that something was deeply wrong. Interestingly, while many places were cold and wet, some areas actually experienced drought too. The whole system was out of whack.
What about Europe? Was it snow there too?
Mostly not snow, but relentless cold, gloomy rain. Think Britain, Ireland, France, Germany, Switzerland. June rainfall was double the average.
Double the rain in June.
Ireland reportedly had 8 solid weeks of rain. Just constant drizzle and gloom. And all that cloud cover meant even less sunlight reaching the ground.
So different impacts. North America freezing, Europe drowning.
Largely, yes.
Yeah.
Though both cold. And there's evidence the whole atmospheric circulation shifted. The big monsoon rains in Asia and Africa might have been weakened or disrupted.
So the effects rippled out very far.
Very far. Though it wasn't uniform. Eastern Spain was apparently drier. Parts of Eastern Europe might have even been a bit warmer. It's complex how the global cooling played out regionally.
We have first-hand accounts, right, from people who lived through it.
We do, thankfully. They really bring it home. Thomas Jefferson, always the observer, called it the most extraordinary year of drought and cold.
Even Jefferson was struck by it.
Oh, yes. A guy in Connecticut, Chauncey Jerome, remembered needing mittens in June, seeing people in overcoats on the 4th of July.
Overcoats on July 4th.
And Hannah Dawes Newcomb, up in New Hampshire, wrote in her diary about the constant cold gloom, needing fires every single day in July just to stay warm indoors.
Fires in July, just basic survival.
Newspapers were full of it. Reports of the frosts, the weirdness of the weather. A letter from Paris flat out stated it was the coldest season anyone alive could remember. These personal stories hit hard.
They really do. It wasn't just numbers, it was lived misery.
Exactly. Constant discomfort, constant worry about food, profound confusion about what was happening to their world.
Now, it's important to add, Tambora wasn't the only factor making 1816 so bad, was it? There was context.
That's a crucial point, yes. 1816 happened near the tail end of the Little Ice Age, a longer period of generally cooler global temperatures.
Okay, so the climate was already a bit cool.
And it also coincided with something called the Dalton minimum, a period when the sun itself was less active, putting out slightly less energy.
Lower solar activity.
Plus, there had been a few other moderate volcanic eruptions in the years before Tambora. Nothing on its scale, but they might have already injected some aerosols, subtly cooling things already.
So Tambora was like the knockout blow to an already stressed system.
That's a great way to put it. It hit a climate system that was already a bit fragile and amplified everything dramatically, pushed it over the edge into truly extreme conditions. It was a perfect storm, unfortunately.
And the result of all this climate chaos, catastrophic crop failures.
Across the board in the Northern Hemisphere, historian John D. Post called it the last great subsistence crisis in the Western world.
The last great subsistence crisis. That really puts it in perspective. Famine, basically.
Widespread famine, yes. In North America, particularly in New England, maybe 3/4 of the corn crop, a vital staple, was lost.
3/4.
Farmers tried replanting again and again, but the frost kept coming. Hay for animal feed failed too.
So farmers had to make terrible choices.
Heartbreaking choices. Slaughter livestock they couldn't feed or use precious, expensive grain to keep them alive. Vegetables failed. The growing season was just slashed.
And you mentioned the Lincoln family.
Yeah, it's likely that young Abraham Lincoln's family, living in Kentucky then, faced a hungry winter because of these shortages. The impact reached far. Canada saw similar hardships.
Europe was just as bad.
Just as bad, if not worse in some areas. Wheat, oats, potatoes, staples across Britain, Ireland, France, Switzerland, Germany, they failed widely.
Vineyards, too. For wine.
Grapes failed to ripen, and even the grain that was harvested often rotted because it was so relentlessly damp and cold. Fruit in Spain and Portugal was poor quality. Cereals ripened late.
And beyond Europe and North America.
China saw terrible floods leading to famine. And as we mentioned, India's monsoon was disrupted. It was genuinely a global food catastrophe.
With crops failing everywhere, food prices must have gone through the roof.
Exploded. Oats in the U.S., just as one example, jumped from 12 cents a bushel to 92 cents. That's almost an eightfold increase.
Wow. Hay in New Hampshire went up 6 times in price.
Grain shortages plagued Europe. And remember, transportation was terrible back then. You couldn't easily ship food from a place that had a bit extra to a place that was starving.
So local failures meant local starvation?
Pretty much. The lack of infrastructure made everything worse. People just couldn't afford basic food.
And the economic fallout lasted longer. You mentioned a possible link to the Panic of 1819 in the U.S.
Yes, some historians argue that. The idea is agricultural speculators bet on high prices continuing after 1816. But when European harvests eventually recovered, prices dropped, and those speculators were ruined, contributing to the wider financial panic.
So the ripples just kept spreading.
Absolutely. A natural disaster triggering long-lasting economic consequences.
With hunger comes desperation and often social unrest. Did that happen?
It definitely did. We see reports of food riots erupting in Britain, France, Switzerland. People were desperate, angry.
Communities breaking down.
In some places, yes. People forced into begging. Crime rates went up. The psychological strain must have been immense.
People resorting to desperate measures for food.
Foraging for anything edible. Wild plants. There are grim reports of people eating hedgehogs. In Yunnan, China, the famine was horrific. Accounts mention eating clay, even selling children.
It's unimaginable desperation.
It truly is a complete breakdown of normal life.
Did this crisis push people to move? To migrate?
It seems so. In North America, the constant failures in New England likely spurred the westward migration. People heading to Ohio, Indiana, Illinois, looking for better land, a fresh start.
The year without a summer helped populate the Midwest.
It probably contributed significantly, yes. And similarly, in Europe, the hardship likely boosted immigration, particularly to the Americas, in the following years.
People fleeing hunger and poverty.
Exactly. Seeking opportunity elsewhere when things are so bleak at home.
And disease. Famine and disease often go hand in hand, don't they?
Tragically, yes. Malnutrition weakens the immune system terribly. Typhus epidemics swept through Europe between 1816 and 1819.
Typhus?
Killed over 65,000 people in Britain and Ireland alone, just from that.
Hell.
And widespread undernourishment likely meant fewer babies were born or survived infancy. Lower birth cohorts.
A public health disaster on top of the famine.
Layered tragedies.
And then there's that really startling hypothesis connecting Tambora to cholera.
Yes, it's a compelling theory. The first global cholera pandemic started in Bengal, India in 1817, right after Tambora's climate chaos.
How would the volcano cause cholera?
The idea is that the disrupted monsoon patterns, maybe drought followed by heavy floods, caused by Tambora's atmospheric effects created conditions in Bengal that triggered a mutation in the existing cholera bacteria, made it more virulent, more dangerous.
And populations were already weak from food shortages.
Exactly. Malnourished, vulnerable populations. This new aggressive cholera strain then spread like wildfire across Asia, the Middle East, Africa, eventually killing millions.
Wow. A volcanic eruption in Indonesia potentially triggering a global cholera pandemic originating in India.
It's a shocking potential chain reaction. It's still debated by scientists. The timing and the potential mechanism are plausible. It really highlights these unexpected, devastating ripple effects through Earth systems and onto human health.
This whole story, this cascade, eruption, climate chaos, famine, disease, migration, economic turmoil. It just hammers home how connected everything is.
It really does. Natural systems, human systems, they're deeply intertwined. And it shows how vulnerable societies were, and perhaps still are, to abrupt environmental shocks.
So, faced with this completely bizarre weather in 1816, how did people even try to explain it? They didn't know about stratospheric aerosols.
Right. The actual cause was invisible, distant, and delayed. So they grasped for explanations within their own understanding of the world.
Religion must have played a big role.
A huge role for many, seeing it as divine displeasure. A punishment for sins, a call to repent. Church attendance reportedly went up, religious revivals happened.
Makes sense. When the natural world goes haywire, people look for supernatural meaning.
Absolutely. There's even a folktale from Sumbawa itself, attributing the Tambora eruption to the wrath of Allah because of some local transgression. Existing beliefs about weather, omens, maybe even the end times, were likely amplified by how weird everything felt and looked.
And what about more? Natural explanations, early scientific ideas.
People tried. They looked at what they could see. Sunspots were a really popular theory.
Because the haze made them more visible.
Exactly. It was also the Dalton minimum, low solar activity anyway. So people saw the spots, felt the cold, and thought, aha, connection, even though it wasn't the right one.
What else did they blame?
Oh, earthquakes, maybe deforestation changing local weather. Benjamin Franklin had actually speculated years earlier that volcanic fog could cause cold weather.
Franklin was onto something.
He was, sort of, but his idea wasn't widely known or specifically linked to Tambora at the time. People were basically using the limited science they had, looking for local or visible causes.
How long did it actually take for science to connect Tambora to 1816?
Decades, really. The key work solidifying the link came much later, from William Humphreys in 1913.
1913, nearly a century later.
Yeah, it shows the limits of 19th century science and communication. Understanding atmospheric physics, global circulation, how aerosols work way up high, that took time to develop.
So their attempts to explain it really show us their worldview. Local observations, religion, folklore, very early science.
Exactly. Without that global perspective, without understanding invisible atmospheric chemistry, they focused on what they could see or what their culture already taught them. It proved how hard it is to grasp huge environmental changes when the cause is far away and unseen.
Okay, but amidst all this darkness and hardship, paradoxically, there was this burst of creativity.
It's one of the most fascinating twists in the story. Even with all the suffering, the gloom seems to have ignited some incredible artistic and literary sparks. Human resilience, I suppose.
The most famous example has to be that summer gathering at Lake Geneva, right? Villa Diodati.
Oh, absolutely iconic. Lord Byron, Percy Bysshe Shelley, Mary Godwin, soon to be Shelley, Byron's Dr. John Polidori, and Mary's stepsister, Claire Clairmont, stuck indoors.
Because of the awful weather, the cold, the rain.
Exactly. Relentless bad weather keeping this group of brilliant, maybe somewhat restless romantics cooped up together. They started reading German ghost stories to pass the time.
And Byron had an idea.
He proposed a challenge. Let's all write our own ghost story, just like that. A board challenge on a gloomy summer day.
And from that challenge came Frankenstein.
Mary Shelley's Frankenstein. She had this incredibly vivid waking dream, as she called it, fueled by their conversations about science, life, death, and probably the oppressive atmosphere outside. The novel's dark, brooding mood perfectly captures that gloomy summer.
An immortal monster born from a volcanic winter. Incredible.
Isn't it? The themes in the book, unnatural creation, nature's power, science gone wrong, they resonate so strongly with the anxieties of a time when the natural world itself seemed out of control.
And that wasn't the only monster born that summer. What about vampires?
Right. Byron himself starts sketching out a vampire story. He didn't finish it, but his doctor, Polidori, picked up the idea and ran with it.
Creating the vampire.
The Vampire, published in 1819, and it's basically the prototype for the suave, aristocratic, dangerous vampire we know today. It heavily influenced Bram Stoker's Dracula later on.
So Tambora indirectly gave us both Frankenstein's monster and the modern literary vampire.
It seems so. That gloomy summer at Villa Diodati was remarkably productive for the horror genre.
Byron also wrote a poem that summer, Darkness, didn't he? Reflecting the mood.
He did. It's incredibly bleak. It imagines the sun being extinguished entirely, plunging the world into a frozen, lifeless night, really captures the apocalyptic fear some must have felt.
Those lines you quoted earlier, the bright sun was extinguished. The icy earth swung blind and blackening, chilling.
It's pure Gothic horror, mirroring the literal and metaphorical darkness of the time.
But the volcano didn't only bring darkness, it also brought spectacular sunsets.
Ironically, yes. Those stratospheric aerosols didn't just block sunlight. They scattered it in unique ways, especially at dawn and dusk.
Creating unusually vivid colors.
Brilliant reds, oranges, yellows. These lasted for up to 3 years after the eruption. And we have visual proof.
J.M.W. Turner, the painter.
The great British painter J.M.W. Turner. He was obsessed with light and atmosphere, and his paintings from that period, 1816, 1817, 1818, feature these absolutely stunning fiery sunsets.
And scientists have actually analyzed his paintings.
They have. They measured the ratio of red to green light in the skies Turner painted, and found it correlates statistically with known periods of high volcanic aerosols in the atmosphere.
So his art is like an accidental scientific record of the atmospheric conditions.
In a way, yes. capturing the optical effects of Tambora's lingering haze. It's fascinating. His later move to even hazier styles might also reflect growing industrial pollution, another atmospheric change.
One more potential and maybe unexpected consequence, the bicycle.
The precursor to it, yes. The Lauf machine, or running machine, invented by Karl Drais in Germany around 1817-1818.
How is that linked to Tambora?
The link is the oat crisis. Remember the crop failures, especially grains like oats needed to feed horses.
Right, massive shortages, soaring prices.
So horses became incredibly expensive to keep and use for transport. The theory is this widespread horse crisis spurred Drais to develop and promote his invention as a human-powered alternative, a way to get around without needing oats.
A mechanical horse born from famine.
Potentially. We can't prove it definitively, but the timing is highly suggestive. The fodder crisis was severe, and there's even a German commemorative coin showing Grace's machine and a volcano, so the connection is certainly part of the story.
Wow, so the fallout includes gothic horror, apocalyptic poetry, amazing art, and maybe even the invention of the bicycle.
It's an incredible range of impacts, showing how devastation can also act as this strange, harsh catalyst for creativity and innovation.
Okay, time for some deep cuts, those specific, lesser-known details that really make you say, wow.
All right, let's start back with Thomas Jefferson, meticulously measuring rainfall at Monticello, even during the crisis. A true scientist, always observing.
And Hannah Dawes Newcomb's diary phrase, cold gloom, so simple, so evocative of the feeling of that summer.
Perfect. Or the Paris correspondent just flatly saying, coldest season in living memory. No ambiguity there.
How about the sound of Tambora being mistaken for naval battles? Thousands of kilometers away, just staggering power.
And the complete wiping out of the Tambora princedom, tied to that local folklore about Allah's wrath, shows the immediate human cost and how cultures process catastrophe.
Thinking about young Abe Lincoln in Kentucky, probably facing a tough, hungry winter due to weather caused by a volcano he'd never heard of.
Really connects it to familiar history, or the sunspots becoming visible, and everyone latching onto that as the explanation. Shows people trying to make sense of the terrifying unknown with the tools they had.
What about that weird Arctic warming?
Yeah, counterintuitive, altered circulation, briefly melted some ice, got people interested in the Northwest Passage again, shows the complexity, not just uniform cooling everywhere.
The link between the Yunnan famine in China and the subsequent shift to growing opium poppies, a long-term tragic consequence born from desperation.
Definitely. Or the idea that Justus von Liebig, the future father of agricultural chemistry, experienced the German famine as a kid. Did that fuel his drive to prevent future famines through science? Plausible.
And Carl Drace's dandy horse. It was a fad, but then faded quickly, right?
It did. Shows that even useful inventions don't always catch on immediately. Lots of factors involved. And finally, just remembering it wasn't only Tambora, the Little Ice Age, low solar activity, prior eruptions, they all stacked up.
Right. It was the perfect storm.
A devastatingly perfect storm.
So wrapping up our historic road trip, the story of Tambora and the year without a summer is just, well, it's almost beyond belief. You got this cataclysmic explosion.
Leading to a missing summer thousands of miles away. Famine, disease, social upheaval.
But also these incredible sparks of creativity. Frankenstein, vampires, Turner's sunsets, maybe even the bicycle. It just reveals how deeply interconnected our planet is.
And how powerfully climate events can shape human history, human culture, everything. It's a stark lesson in the fragility of societies facing abrupt environmental change.
A lesson from the past that feels incredibly relevant now as we face our own climate challenges.
Absolutely. The year without a summer wasn't just weird weather. It was a glimpse into how Earth's systems can profoundly impact civilization.
If you want to explore this more, definitely check out the history books and uncovered sources we've drawn on. There are amazing first-hand accounts, scientific papers, cultural analyses out there.
Really dig into the diaries, the science, the art that came out of this extraordinary period.
And here's a final thought for you to take away. In our world, now so clearly being shaped by human impacts on the environment, what kinds of unexpected summers without a summer might we face in the future?
The story of Tambora is a powerful, maybe even chilling, reminder of the huge, interconnected forces that shape our world. Keep exploring these incredible stories history has hidden for us.